Ok, obrigada. Boa tarde a todos, obrigada a todos por estarem aqui. Meu nome é Ana Paula Furlan, eu estou muito contente de apresentar o Dr. Andry Razakamanantsoa para vocês que estão assistindo, eu não sei se é em português ou em inglês, mas vou fazer duas vezes. Ele é pesquisador e diretor do Laboratório de Interação Ambiental e Geomateriais da Universidade Gustave Eiffel, em Nantes, na França. Ele é um colega já antigo, porque essa parceria já está com quase 10 anos, porque a primeira vez que eu estive na França foi em 2014, e depois eu voltei mais outras 3 vezes, e enviei também um aluno para fazer pós-doc, doutorado sanduíche, e no ano passado. Bom, essa parceria ela tem sido possível por causa de financiamentos que nós conseguimos obter graças ao CapSprint da USP e ao CNPq também. O Andry, ele é um doutor em Geomecânica Ambiental pelo Instituto Nacional de Ciências Aplicadas de Lyon, na França. Ele tem especialização em mecânica de poros, estudo multiscala de hidromecânica e comportamento mecânico de geomateriais e durabilidade. Atualmente, os tópicos de interesse são relacionados a geomateriais e interação solo-atmosfera. Bom, agora em inglês. Good afternoon, everyone. My name is Ana Paula Furlan. I'm pleased to introduce Dr. Andry Razakamanantsoa to you. He is a research and director at the Geomaterials and Environmental Interaction Laboratory of Gustave Eiffel University in Nantes, France. I can say that he is a colleague because this partnership is already almost 10 years old. I went to France in 2014 for the first time. After that, I came back 3 more times, 2019, 21, and 23. My PhD student, Mateus, did a postdoc in Nantes, France, with supervised by Andry in 2021. It was possible due to the grants from CapSprint and CNPq. Andry is a PhD in environmental geomechanics from the National Institute of Applied Science in Lyon, France. He is specialized in porous mechanics, multiscale study of hydromechanics, and the chemical behaviors of geomaterials and durability. His major research topics are geomaterials and soil-atmosphere interactions. And now I invite you, Andry, to speak, and thank you to be here, and I'm so happy.
Thank you very much, Anna. Thank you for the invitation, for giving me the floor. It's an honor to be here with you, and it's an honor also to make this talk today. So I go ahead. So today I will talk about earthworks and how to integrate the climate change questions in these aspects. This is a first experience in France and also in Europe. I mean to make an exchange between academics and companies working in earthworks area. Okay, so I will not talk about me because Anna explained more. Okay, the context is today we are aware about all questions related to global change, ODD goals, and so on. But in earthworks and in road infrastructure in general, the question remains focused on eco-friendly infrastructure from the implementation till the deconstruction, involving all the different steps. Also about the economy of resource, mainly water, because when we talk about the global warming, it's a question of water, it's a question of renewable materials. And after, about the durability of a structure, and the last but not the least, which is very important, the health consideration around the earthwork application and the road in general. I mean, air quality. When you talk about road infrastructure and so on, in our mind, we have when we talk about soil, we talk about stabilization. How to stabilize the soil in order to have the recommended strength in order to support traffic and all the activities above. I understand during my stay here in Brazil that the way of designing a road in Brazil is a little bit different from the practice that we have in France. But the most interesting thing is that we make focus on the soil more than to the asphalt in the consideration of designing. That means that the question that we will talk today is something in your interest, I mean, because we will talk about soil stabilization, durability, and degradability, and all the question related to the environment, security and safety, and health. So, considering the soil classification in France, which is not exactly the same also in Brazil, but I think that you know more or less the parameters that I present. In Europe, when we try to select a type of binder which is used for soil stabilization, we have to consider the climatic condition, which is arid, tempéré, or semi-tropical, but most of the time we have a climate tempéré, and wet or dry. So for that we use the plasticity index, and also to verify if you have an organic matter or not inside the soil. Based on that, we try to select product. This is a way of selecting the product which is recognized for soil stabilization, because now we have to consider the environment aspects. I mean, how harmful is the product against the environment. So, if you consider the different types of product that is available, I didn't put here the lime and cement because it's a conventional product, but for the rest, we have to consider these aspects. I mean, the volume of traffic, mainly when we talk about soil stabilization in Europe, we consider that we have low traffic mainly, which is not the case here. We have an intense traffic in Brazil, as I understand. So we consider the materials, its plasticity, and the quantity of fine inside. I mean, we consider the clay activities of the soil, and after we involve the climate during traffic. So this is an example of soil classification involving the traffic. But regarding all of those products, the less expensive is the water, and we use water in quantity in earthwork construction. So in the following phases, I will talk mainly about the economy of water and the use in earthwork, and how to optimize the use of water in order to optimize also the strength and the implementation, the strength and the traffic ability on the road. Let's talk about the implementation. When you talk about implementation of road or unpaved road, this is an example of a structure of unpaved road. I go ahead. One parameter which is important is the compaction. The compaction level. I don't know if you have a ship foot roller in Brazil. I think no. This one. I think that it's the same use as in Europe. We use ship foot compactor when we have a fine soil, when you have a clayey soil, when you have lateritic soil with high quantity of fine. And as you see, we are not able to reproduce this mechanism of compaction in laboratory. Or today, when we design roads, earthwork or earth structure, we base the mechanism of compaction, which is well known, Proctor, and you do the calculation based on that. So today we consider that many things was been done in this way, but many things, many disorders remains less explained until now. For example, the rotting, you are not able to understand that in laboratory point of view, but we see that in reality, it's real life. So we tried to, by considering the climate change and the resource saving and water saving, we tried to think and to work about to try to understand the mechanisms governed by the need in compaction. So when you consider the ship foot compactor, what is this? It's a combination of roller compaction with kneading compaction, which is two complementary process. Let's talk about step by step roller and kneading compaction. When we talk about roller compaction, I will go to the. I won't go in deep, but just globally, when during rolling a wheel, we have stress tensor rotation, and during the rotation of a wheel, so we have an additional stress tensor which enhance the soil compaction. This is the case of a roller compaction. I won't talk about Terzaghi and so. We can discuss about it later if you need. So we try to reproduce this way of compaction in laboratory. For that, we have used something that is used for asphalt. I don't know, maybe you have here to compact the asphalt. We compact the soil in the same way, with a detail about the level of compaction stress, which correspond to the main current compactor that used in field. I mean, considering the scale effect. So we did a comparison because today we don't have we have zero data corresponding to the compaction effect, roller compaction effect. So what we got by varying the water content from 0.75 to optimum water content. This water content is the water required to reach the optimum dry density. And we have these similarities. This is standard Proctor, and this is roller compactor. The lesson that we can learn here is that we can reach the same level of compaction as we got with standard Proctor. But when we go ahead and take a look about the microstructure, I mean, when you do the analysis of a pore size distribution inside the soil, same stress, same test configuration, we have a difference. I mean, when you rise the compaction effort, we close the wider pore when we do compaction, roller compaction. This is an interesting thing because we cannot have that with Proctor compaction because we have an unique vertical blow. We go ahead. We did a comparison between laboratory roller compaction with the same soil, vs field. I mean, we compact the same soil in field, and we sample, and we did microstructure analysis, and we got something like that. I mean, we have quite similar wider pore and quite similar smaller pore. We consider that the difference of level is due to the difference of scale mainly, because we have exactly the same grain size distribution. We try to check also by SEM image what is inside when we have a sample which is compact by smooth roller, and in laboratory you see the difference of texture, which is a little bit important. So what is the lesson that we learned from now? It's just an observation and a kind of autopsy, not a quantification from now. The change due to compaction impact the interaggregate pore, mainly for soil submitted to roller compaction. The next step is to consider the scale effect. I think that it's not significant, but it's necessary to have a rigorous approach. So the main important thing to get in our mind is that when you have a fine-grained soil, during wetting, you create an aggregate, and during compaction, you reduce just the space between aggregates, but you don't touch the size nor the shape of the aggregate. It's an important thing that we will implement after. Let's talk now about kneading compaction. Kneading compaction is used mainly in France for lime or cement treated soil. So for that, we worked with a company, Loist, who produced the lime, and we did a lime treatment to see whether what is the gain by kneading compaction. This is the company's interest, but for us, the aim is to understand the mechanism of kneading action. For that, we have 3 points. The first point was to understand the kneading effect on the strength of lime-treated soil after the hydraulic conductivity performance and laboratory and field conditions. To investigate the permeability, we use a flexible wall permeameter, and we did UCS for mechanics and ICP to analyze the water which goes out. Rapidly, what was been read in the literature is that when we use compaction, kneading compaction, we can compact the soil in the wet side of Proctor. We verified it with the example that we have here. By Proctor, we get 0.8 megapascal. By kneading compaction, we have more than 1.2. So we verified what was been shown in literature. Also, for permeability, you get the same things. In this aspect, excuse me for presentation, particularly one important thing to consider is that when we do compaction of soil, we have to take care about the nature of a testing solution. That means we have to go to take a solution, water or another thing, which is very close to the condition that we'll get in field, because we have a different leaching mechanism between the materials. In terms of pore size distribution, we see the difference. Kneading compaction reduce the pore in different level, the intensity and the size. which is not the case for Proctor, mainly the wider pore. Go ahead. So now we understand more, we have more information about rolling and kneading compaction. Now the shipfoot compaction is a combination of rolling and kneading. So let's go about the road traffic. Today also we don't have any experience about the rolling traffic at laboratory scale. I mean at the scale of sample scale. We try to produce different types of tests, but more or less the mechanism is remains less understood. So we go again about with Le Carp about the stress tensor rotation, and we do a kind of we built a specimen, and I don't know if you have this kind of rolling machine, which is used for asphalt mainly, as Patricia knows, I guess. So we use that for soil. I mean, we apply a number of cycles of traffic, and what is the fact that we get is that during traffic, a certain number of traffic, we take out the aggregate that we have formed after wetting. And the more we go in terms of number of traffic cycles, we degrade the aggregate till the initial state of soil. And this is a mechanism of dust production in unpaved road in general. This test was been done with, that the show was been done with smooth tire, but we have done exactly the similar thing with different sculpture of wheel. So now we have the particles on the surface of soil. These particles are able to go in the air and to become to form a cloud of dust. From now, the question is that how to reduce the dust production, the generation of production by means of compaction. So, because this is an interesting economy in field, because you reduce the quantity of water, and you reduce also the number of entretien. I couldn't find the word. So we try to test different configuration of compaction and wetting of soil. A, B, C, and drying. The idea is to find in an unpaved road which configuration is better. Is it necessary to compact at optimum? It's not the case when we talk about unpaved road, because we have directly a rotting. Is it necessary to compact in C? It's not the case also, because we will have the wheel will go inside, so we don't have a sufficient bearing capacity. So the idea is to test in this point, but the question is that is necessary to compact directly in a dry state until the optimum proctor, or to compact at proctor and to dry it. So we have a different drying path, which is interesting to investigate in terms of soil mechanic, unsaturated soil mechanic. But what we did is that to try to make a traffic test above it. And the result, so what we did is to measure the vertical deformation against a number of cycles. And after we built a kind of parameter which is the surface degradation, and with this parameter we are able to compare different drying and wetting path. Each of these grain parameters, we use also the grain size distribution of the particle which is collected from the surface in order to assess kind of evolution of grain size distribution of particles. And we combine these two parameters to assess the degradability of the soil. So by means of that, we get the main mechanism of aggregate formation and degradation, surface degradation. So rich with all of these informations, we worked with National Federation of Earthworks in France to help them in order to have a kind of guide to help them about earthworks application. So to give an example, in France, earthwork is the main activities which use a huge quantity of water, and their goal was to reduce 50% of use of water in their daily activities. But the problem that they are not able to estimate the quantity, so we do it in different way. So we wrote a guide to the earthworks, all the Federation of Earthworks companies in France, by using the soil classification in France. I mean, in this table, you have the soil classification rapidly is a combination of grain size distribution, methylene blue value, and plasticity index. With these three parameters, you can classify the soil against or according to the quality of the soil. So mainly the soil which can be subjected to dust emission is A soil. In the new soil classification, it becomes F soil. So from silt till clay, highly clay. So this is the guide. The guide is composed with 4 steps. First one, we identify the source of dust emission. Second thing is to analyze the soil properties and the device which is in the quarry or in the earthwork fields. And after, analyze the environment, immediate environment on the site, and give recommendations. The first step is about identification of dust emission. Mainly, how to say that, the nuisance, no? Yes? I cannot find the word, nuisance. Yeah, okay. The impact of dust emission is firstly the decrease of visibility in field. Second thing is the leaf of all vegetables are mainly covered by dust, and the activities of plant is reduced also. And after, it enhances a pollution of natural spaces. Go ahead. So, based on the soil classification in France, and mainly about methylene blue values, we can consider the different types of soil. And based on these different types of soil, we can adjust the quantity of water that we have a requirement of a quantity of water which can be provided. And for that, we use the degradation surface degradability that we have developed previously as a parameter, and we combine with the fine fraction. Based with this combination, we can say exactly which quantity of water is needed for this activity. After, we can classify also the soil according to the level of degradability considering the actual number which will be applied in the traffic. And after, the last but not the least, we tried to assess the ability of one material to produce fine particles before we come in field. I mean, we have an idea about the quantity, the potential of emission of materials. I will show you after how to do, and after it's environmental recommendation. These are the main and the recommendations. These are the main different steps of good practice, which is provided by the university to the Federation of Earthwork in France, and they use this guide to adjust the use of water. So this is the first action about water saving. Next one, how to optimize the quantity of water if we know that we have a soil which has a potential of dust emission. For that, we based on the device or the machine that they have in field, we do a kind of chart based which will link the quantity of water and the speed, the velocity of the vehicle or during traffic. And let's talk now about the potential of dust emission. This is a patented device which was developed to assess the impact of decrease of visibility due to dust emission. And it's very simple. We send a high velocity in high velocity and suppressed air, and we create clouds of particles. We can use sand or sugar or another powder, but the aim is to produce fine particles, clouds, and we count the particle with counter particles, and we measure at the same time the environment, relative humidity, temperature, and sunlight. And for that, this is the theoretical aspect, but I will not talk about that. We have this kind of parameter which is called potentiel d'envol, which is the tangent theta. Theta is this angle, which is the exposure duration and the concentration of particle matters that we collected, and divided by relative humidity. Each soil particles, it's a parameter, intrinsic parameters for each soil. It's different for each soil. So we can use that to classify the soil and its ability to produce particles, fine particles. Now, how about dust particles emission? So if you remember, now we have particles on the surface. What are the conditions, the sufficient condition for their particles to become dust, as you can see here? So we try to, just for your information, when you talk about particle matters, we talk about fine particles. It involves particles which size is 0.1 till 10 micrometers. To give an idea, 10 micrometers correspond to our hair, one hair, and 0.1 is we cannot see with our eyes. But if you take into account the health exposure, the more the particle size is small, the particle comes in the deep places in our lung and generate cancer, disease, different diseases. So mainly we focus on 2.5 micrometers. And now we will talk about aerodynamic particles, not size of particle. What is aerodynamic particles? It's just the equivalent particles. This is a particle which shape is we cannot describe, and we take an equivalent diameter which has 1 gram per centimeter cube. So to put in light the mechanism of soil dust emission, we apply cycles of traffic on different types of soil, and we do a testing in a wind tunnel in order to analyze the boundary limit which is required to take off one particles. And for that, we use these parameters, which is shear strength with shear strength required to take out the particles from the soil surface till the air. And to assess the dust emission initiation, we use these parameters, which F is T is this expression. For that, we propose a dust emission flux. This dust emission flux involves all of these parameters, and that we have determined point by point by different types of experiments. What are the lessons that we learned? The fine particles less than 2.5 micrometers is less dependent to the gravity. So that's why it remains long term in the air, and this behavior is independent to the speed of a car or the vehicle, or the wind condition in the field. It was verified in laboratory in wind tunnel, but this was also verified in the field by measurement. So we did measurement in field by means of this track test that maybe you know also. So the idea is to put the dust particles on the road, and they go over with a vehicle, and we count the particles, and we measure the cloud protest. It's something like that, and we record all the parameters which is linked to the momentum generated by the car during the test. We used Ranger Ford and Clio vehicle, and by means of this test, we can calculate the phi as we have estimated in the previous test. This is the evolution of the phi parameters and different quantities of particle in the soil. Lesson that we have learned: from 30 to 60 kilometers per hour, the emission factor goes from 2 to 7, and the Clio emits more dust than the Ford Ranger. This can be explained in the following work. About dust diffusion, we did a test, complementary tests in field by to understand more about exposure risk based on means of mobility. The idea is to test if the low cost sensor to measure to count the dust particle that we have used for our test can be distributed in a space in order to have clear information about the exposure of dust emission in the city, for example, or in a quarry, or in earthwork fields. We did that with different means of transportation: foot, bike, car, and public transportation. And we compare with the official database of air quality, and it gives a similar level. The next step was to put a sensor in different student with different means of transport again, and this in the second step was to go to different places, which is we consider that we have a less exposure. For example, in close to forest or close to river or in the city center. This is, for example, the case of Nantes, where all the road is in red. Red means that we are upper of acceptable values of exposure. And this is another way, which is in the city center also, but where we get a high quantity of particles, where we have how to say that, for electricity, where we have tu sais, les bornes d'électricité. Bornes d'électricité où il y a les transformateurs. So, I mean, all activities which generate an energy produce also fine particles. So, that was our experience from now, but how to adapt, how to consider the climate change, and how to consider also the environment to the activities of earthworks in France. And to go ahead, we have finally the main questions that we have to raise in the question of dust emission is that today l'OMS, ou je ne sais pas comment on traduit hein? OMS, Organisation mondiale de la santé, recommend to give air quality in massive distribution. All the low-cost sensor which exist in the world gives a number of particles. So the game is now to try to find a correlation factor which helps to give particles, to transform the particle numbers into a mass concentration. To deal with that, what we try to do is to go in different places in the world and different activities in the world. For example, in France, we'll pose different sensors in a quarry, in earthwork sites, and in different countries in the world to put sensor in urban and rural condition, and where we have a high difference of air quality. It can be here also. And the idea is to have an overall distribution of air quality and to compare with the main reference, which is given by satellite. So the idea is to combine these two ways of data collecting by using artificial intelligence to analyze the data set, because it's a huge data that we can get. So the next step is to develop a low-cost sensor to assess air quality in open data, to provide to everyone this ability to analyze its own air quality, to concentrate the effort to the conversion between massive content to massive concentration, and to take in consideration the humidity, relative humidity and temperature, and the difference of pressure in atmospheric pressure in all sets that we measure, because this has an impact in the particle emission. And the last one is that this is a question of health exposure. The idea is to follow the particles from soil to our lung by considering the pathogen agent, which can be stacked on the fine particles and to go until our lung. This is a project that is ongoing with CHU of Nantes and a group of researchers in INSERM and other research center in health in France now. So, thank you. Thank you for your attention.
Thank you, André. Nuisance, noise. We forgot. Bom, thank you, André, for the presentation. I think we have some questions to answer.
Okay. It's a pleasure.
But for now, it's the end of this presentation, and thank for you watching by YouTube. And
Thank you.
see you soon.